For this Pencast, little Timmy is at the edge of a cliff that is 15 meters tall and is launched out of a cannon with an initial velocity of 20 meters per second. He also has a jetpack which accelerates him at 5 meters per second squared. For the first portion of this problem, we must find how long it takes little Timmy to reach the ground. First with the jetpack turned off, and second with the jetpack turned on. So with the jetpack turned off, he will hit the ground at the edge of the cliff, which means that if his displacement is 0 at the top of the cliff, then his displacement will be 0 once he lands. So we can find how long this will take using the displacement equals initial velocity times time plus half of acceleration times time squared, although modifying this to be vertical. So that is vertical displacement, vertical initial velocity, and vertical acceleration. Time does not have an x or y because it's time. And so that is 0 equals, well, initial velocity is 20, so that's 20t minus 5, because that's a negative, because down in this instance is being treated as negative, and half of negative 10, which is acceleration due to gravity, is 5. So that is 20t minus 5t squared. And we will be solving for t, which is time. So, first removing 5t and simplifying this to t minus 4, we have found that the time it takes for little Timmy to have a displacement of 0 and thus hit the ground is 4 seconds. So now to the instance of him doing this again, but with the jetpack turned on. Currently we do not need to know how far he goes horizontally, we just need to know that he does move horizontally, because this tells us that he does not land back on the cliff, but instead lands somewhere at the ground beneath the cliff, which is 15 meters down from the cliff. So, if his initial displacement is 0, vertical displacement that is, if his initial vertical displacement is 0, then his final vertical displacement will be negative 15. Thusly, using displacement equals initial velocity times time plus half acceleration times time squared again, and again changing it to be vertical, we can find a very similar negative 15 equals 20t minus 5t squared, with t being time again. And so, moving everything to one side of the equation, 5t squared minus 20t minus 15 equals 0. Now we can remove 5 from the equation because 5 is within each of the terms, is a factor of each of the terms, and so we have 5 times t squared minus 4t minus 3 equals 0. Now we can use the quadratic formula, so that is 4, because negative 4, so that is 4 plus or minus the square root of 16, b squared, 4 squared is 16, minus 4 times 1 times negative 3. That is all over 2a, and a is 1, so that's all over 2. So simplified, that gives us 4 plus or minus the square root of This is positive 12. So that's the square root of 28 over 2, which is either 4.64, which is either 6.45 or negative 0.64. However, negative 0.64 is a negative time, and we are looking for when it hits the ground again, which would mean the time would need to be positive, and sorry, 6.5 again. So we will be using 4.65, and so that is part A through. Now we need to find how long or how far he goes in the horizontal plane, which means that we are looking for horizontal displacement. So yet again, we can use displacement equals initial velocity times time plus half acceleration times time squared, this time modified for horizontal movement. Again, time is not modified by horizontal or vertical. So we are looking for S of x, which is horizontal displacement. We know that his initial horizontal velocity is 0. So that's 0t, which is just 0. His acceleration, however, is not gravity this time, but 5 because of the jetpack. So that's half of 5, so that's 2.5 t squared equals displacement, horizontal displacement, and t is 4.65, so that's 2.5 times 4.65 squared equals the horizontal displacement. So this means his horizontal displacement is 53.96, or if you round to whole numbers, that would be 54, or if you just round to the tenths, 54.0 meters. So now moving on to part C, we must find what is the final velocity right as he would collide with the ground with the jetpack on. So we can find this using vectors. So his horizontal velocity, we can find this using the vector of his horizontal velocity and vertical velocity. But first we must find his final velocity for both vertical and horizontal. So again, using the ever popular displacement equals initial velocity times time plus half acceleration times time squared. Sorry, no, we will not use that any longer. We will use final velocity equals initial velocity plus acceleration times time. So this is So for horizontal, this would be his initial horizontal velocity is 0, and his acceleration is 5, and the time is 4.65. And so we find that his horizontal velocity is 23.2 meters per second. And doing this again for his vertical velocity, his initial velocity in the vertical plane is 20 minus 10, because that is acceleration due to gravity, with acceleration being negative in this instance, times time, which is again 4.65. So 4.65 times negative 10, that's negative 46.4.5. And then adding 20, we can find that his final vertical velocity is negative 26.5. We can have negative for now because with vectors we will be using Pythagorean theorem to find final velocity. So this is final velocity squared equals final horizontal velocity squared plus final vertical velocity squared. So the negative will be taken out by the squaring. So this is 700 for vertical velocity squared plus 539.6 for the horizontal velocity squared equals velocity squared. So that's velocity squared equals 1,239.6. So final velocity is, drumroll please, 35.2 meters per second. However, we also have to find the direction and as well as the magnitude. So we can using our knowledge of vectors, we know that, for instance, I'll move this down here just for easier representation. Sorry. So we know that horizontal velocity is around 23, and vertical velocity is right around 26.5. So, and we know that final velocity, which is right here, is 35.2. So using this in basic trigonometry, we can find this angle. So for this, we will be using vertical velocity, which is 26.5, equals final velocity, 35.2, times sine of the angle. And so dividing final velocity, which is 35.2 again, we'll find that the sine of the angle is 0.75. So using the inverse sine function, you will find that the angle is 48.6 degrees. And this will be below 48.6 degrees below the x-axis, or the horizontal plane, towards the vertical plane. So it could be drawn like this, or it could also be like so, depending on which way the cliff is facing in relation to where your axes are. And so we now know that the final velocity is 35.2 meters per second at 48.6 degrees. And now little Timmy needs to go to the hospital because he broke his legs on the way down. Bye.